पण माझ्या इकडनं जरा प्रॉब्लेम होईल असं वाटतंय मला. या यशोदन वी कॅन स्टार्ट.
Good morning, everyone. I am Yashodhan Deodhar. Welcome to today's program presented by Janaseva Samiti, the Astronomy of Eclipses. We will be beginning in a few short minutes, but please, till then, in the comments box, please tell us if the audio video quality is clear and you have no problems. Good evening, everyone. We will be going live. We will be beginning the program in a few minutes. Till then, please comment in the comment box below if your AV quality is clear. We are waiting for more participants and we will be beginning at 6:05 p.m. Thank you for your comments. We will be beginning in a few minutes as we are waiting for more participants. We will be beginning in a few minutes. We are still waiting for more participants. I realize that this topic is truly intriguing and exciting, but we will be beginning in a few short minutes. Please comment in the comments box if your AV quality is clear. We are waiting for more participants so that we can start very soon. Thank you everyone for your response. We are waiting for more participants. We will be beginning very shortly. Please stay with us. I know that you are all eagerly waiting for this program to start. So are we. But we are waiting for more participants. So please be with us for a few more minutes. We will be starting very shortly. Hello, everyone, and good evening. Welcome to today's program, The Astronomy of Eclipses. Before we begin, I would like to state that last year, lockdown forced us to shut down all our in person programs. To overcome this lacuna, we adopted the digital platform to organize various informative programs. This technology was amicably and suitably adopted to perfection, and since then, we have completed over 53 successful programs, one almost every Sunday in a span of one short year. Moving on, today's topic eclipses is indeed different and equally intriguing. We all have heard of eclipses, both solar and lunar. Unfortunately, many of us have heard of them in the wrong context of omens and what to do or not to do. Few have been interested in the cosmic events that lead to the occurrence of eclipses. In recent times, a major solar eclipse will be occurring on the 10th of June. Although it is not visible from India, it indeed presents an amazing opportunity to learn the astrophysics behind it. I would like to point out here that astronomy requiring extensive study and research is a common misconception. With a commerce degree in hand, today's speaker, Mr. Shishir Deshmukh, proves that all an enthusiast needs is a keen interest, as amateur astronomy is more observational than mathematical. The treasurer of NGO Akash Mitra Kalyan, Mr. Shishir Deshmukh, is the first Indian discoverer of a SOHO comet and has reported over 100 minor belt asteroids and various stars. During his career, he has collaborated with NASA, the European Space Agency, the International Meteor Organization, and the Minor Planet Center at Harvard. His works have been facilitated at the hands of eminent personalities such as Dr. Anil Kakodkar and our former president, Dr. APJ Abdul Kalam. He has authored the book The Astronomy of Eclipses with Mr. Hemant Mone. His papers have been published in the Journal of Double Star Observations, Minor Planet Bulletin, and the Journal of American Association of Variable Stars. He has also written various articles in regional newspapers as well as the well known magazine Science Reporter. Before we begin, I would like to mention that the last 10 to 15 minutes of this program have been reserved for question and answers. So, if you have any questions regarding this topic, feel free to type them in the comments box below and we will address them at the end. I now hand over the program to Shishir sir. Thank you.
Thank you, Yashodhan. Thank you for your elaborate introduction. And thank you, Parag Lime and Bella Madam and entire team of Janaseva Samiti, Parle. It's been pleasure to be here and share the audience and share my thoughts with this learned audience. And I really appreciate the way Janaseva Samiti is doing work for last 1 year. And we all know how traumatic last year was. And within that year also, what Janaseva Samiti was doing and is doing a wonderful and commendable job. So I wish them all the best for their next endeavors. And now I will straight away begin with my presentation. As announced, today we will be discussing about the eclipses. And as we all know, eclipses are much discussed and probably a little misunderstood topics in the astronomy. But yet, having said that, I would like to highlight here today that eclipses in general are extremely beautiful events of the nature. And if you go and observe an eclipse, especially this solar eclipse, then it would be a lifetime experience, that is for sure. So in today's presentation, I would like to discuss at least some of the aspects of eclipses, because eclipse in itself is a very vast topic. At least you need an entire week to discuss the all aspects of eclipses. But nevertheless, today we will be discussing right from basics of the eclipses that most of you must have learned about them in your school days. And we will be going through some of the advanced aspects of the eclipses which are lesser known. So I would like to pull everything and make it concise to 1 hour discussion today. So in probably in the earlier the first phase of my session, I'll be a little bit fast because it is a very basic concepts and most of you may be already aware of it. So let us begin our discussion. I'll be sharing my screen. I hope it is visible. Can Yashodhan please confirm this?
Yes, sir, it is visible.
Thank you, Yashodhan. So today we will begin with the eclipses of the moon first, and then later on we will discuss about the solar eclipses. When I say it is eclipses of the moon, intermittently I'll be referring them as lunar eclipses also. Lunar eclipse means Chandra Grahan or eclipse of the moon. So let us first try to understand how this entire eclipse phenomena runs. So it's basically a celestial shadow play. And when I say shadow play, it has got three sources, three main objects. One is light source, one opaque object, and a medium on which shadow falls. So basically, these three things are required to have an eclipse. Basically, these three things are very important. And as far as solar eclipses are concerned, these three parts are played by sun, moon, and the earth. Obviously, these are the three bodies that play a role in eclipses. Sun, which is a light source, moon is an opaque body in case of solar eclipses, and earth, which acts as a curtain or the medium on which the shadow falls. So you can see that when in the solar eclipse moons, it is the moon that comes between the earth and the sun, and its shadow falls on the earth. But contrary to it, in a lunar eclipse, it is the earth that plays a part of an opaque body, and it is the moon which acts as a medium on which the shadow falls. Or in fact, moon comes into the shadow of the earth. So these are the basic concepts. Everybody must be aware of this. Then going little ahead, what is the circumstances wherein these eclipses occur? So same thing, slightly different way I have put it in. On the left, you can see the sunlight. This is the source of the light, that is the sun. And then in this case, this is a solar eclipse. So that's why you can see this is a position of a new moon. By new moon, it is Amavasya. In astronomy, Amavasya is called new moon. So new moon means Amavasya, you can't see moon generally. But in case of solar eclipse, you might get a slight the silhouette image of the moon that is obscuring the sun. And in case of lunar eclipse, you can see that Earth's shadow is falling in the space, and moon is just coming into that shadow. And that's why you can see the lunar eclipse. This is a simple concept that almost everyone may be aware of. Now the big question is that if I'm saying that lunar eclipse occurs on full moon, then why can't be there 12 eclipses in a year, since there are 12 full moons in the year? The question is quite obvious, and we need to understand why it doesn't really occur, why there are no eclipse every month. The simplest reason is that there is an angle between the orbit of the earth and orbit of the moon. The plane in which the earth moves around the sun is slightly different than the orbit of the moon. So in a way, you can see here the moon's orbit is tilted with an angle of 5 degrees only. So gray color is the plane of the earth, and this one is the tilted orbit shown here is the orbit of the moon. And moon revolves in such a fashion, and you can see that it is making an angle of 5 degrees. So what happens? Because of this angle, sometimes it is above the plane of the earth, and sometimes it is below the plane of the earth. So these are different planes in which it is traveling around the earth. So what happens? Particularly, for example, in most full moons, what happens is that moons remains at far north or far south of the Earth's shadow. So this is a typical full moon position. Supposing sun is at the left and sunlight is falling in this direction. You can see the shadow of the Earth here, and moon is not coming in the shadow because it is not in the same plane. So it is as simple as that. So moral of the story is that lunar eclipse does not occur on each full moon because of the difference in the orbital planes of the Earth and the moon. So I think this is pretty easy to understand, and I have tried to design my slides as simple as possible to make the concepts clear. Although needless to say that it is not to the scale, but just to understand the concept, I think it is sufficing the purpose. Now let us we talked about the shadows. Now eclipses is all about shadows basically. And if you see, in case of lunar eclipses, it is the Earth that comes between moon and the sun. So Earth's shadow will be falling in the space. But since Earth is an extended, so it's a huge object, so its shadow is not a single shadow. It is a composite of two shadows. One is umbra, which is a dark shadow, and second was is penumbra, that chaya and viral chaya. So these are two different kinds of shadows, and these are nothing but the concentric circles. So because of the sun is also an extended object, the sun rays falling on the Earth cast shadows in two types, umbra and penumbra. And we'll see a little more about umbra and penumbra. So this is yet another manifestation of the umbra and penumbra. As I said, it is making is creating two kind of shadows. Now in next, this is very important because in this shadow you will come to know how this lunar eclipse plays, how these shadows plays a very important role in lunar eclipses. See, the same umbra penumbra we are talking about now, and as seen from the Earth, if you are situated on the Earth, and if you are looking in the space in the direction in which the Earth's shadow is falling. So now if we look at this direction, we can't see shadow unless there is some object which is on which the shadow will be falling on. So moon plays that role, but at the point at which the moon crosses this shadow, that marks the vertical cross section of this shadow, vertical cross sections of this shadow. Now, as seen from the Earth, now we are looking from the Earth, and in this somewhere in the space, these are two concentric circles which are depicting the umbra and penumbra. And since we are located on the Earth and we are seeing in the space in the direction of the shadow, we'll see that this is the orbital plane, the dotted line you can see. This is the orbital plane of the Earth, and these are the concentric circles of umbra and penumbra. So now what happens is that, as I told in the previous slide, moon's orbit is not coinciding with Earth's revolutionary plane. It is making an angle. So that angle, 5-degree angle, is here. So it may cross this shadow in this fashion. It may cross this shadow in this fashion. And it is the passing of that shadow, or the passing of the moon through that shadow, that makes different types of eclipses. Different types of eclipses. So that is a point to be noted here. So now this, as you can see, that Earth's orbital plane around the sun is one plane, and intersecting that is the orbital plane of the moon. So these two orbital planes are just like a giant rings, you can say. So those two rings are intersecting each other at 2 points, exactly opposite to one another. So these are called nodes, or more popularly, these are called Pathabindu. And I will tell you the names of those very infamous quantities in the astronomy. I'll come to that. So this is one of the node where the intersection point is there. So had this been this shadow been here, then moon would have passed right through the center of the shadow. But in this case, full moon occurred at this position. So the trajectory of the moon would be like this. Okay. So these are the different trajectories in which the moon can pass through the shadow of the earth. These are the different trajectories. Okay. These are different trajectories. Moon can pass this way because full moon can occur at any place in the orbit of the moon, right? So there can be an occasion where the full moon, at the full moon, the moon was somewhere passing, the trajectory of moon's orbit was like this. Sometimes it may directly pass through the shadow. So there can be an eclipse in this case. In this case also there can be eclipse, but only this penumbral shadow which the moon will be intersecting. So these are different shadows and the paths of the moon across it. So depending on the trajectories of the moon through the shadow of the earth, there can be 3 different types of eclipses. This is penumbral eclipses. Why this is called penumbral eclipse? Very simple reason. It is passing through the penumbra of the earth. So it is only passing through the penumbra. Viral chayatna fakta jato. So that's why you might have seen, you might have read about this in a calendar. Chaya Kalpa Chandragrahan. Kiva Mande Chandragrahan. It is nothing but the penumbral eclipse. So it is very hard to visualize this eclipse because moon passes through only the sparse shadow of the earth. So there is no darkening of the moon, apparent darkening of the moon. Only the experienced observer might feel that, oh yes, today the moon is slightly looking pale. So only experienced observers can detect that slight dimming of the moon. Then in second case, it can be a partial eclipse because it passes through penumbra as well as some part of the moon can be covered under umbra also. So that's why it is called partial eclipse. Khandagras Chandragrahan. Khandagras. Then this is total, obviously, because this is passing right through penumbra as well as umbra. So during this passage, it will be a total lunar eclipse. Khagras Chandragrahan. So this is Chaya Kalpa Chandragrahan. This is Khandagras Chandragrahan, and this is Khagras Chandragrahan. Partial, penumbral, partial, and total lunar eclipse. So it is the shadow, the trajectory of the moon that decides the type of eclipse. That's the take-home message for this. So now one more thing I would like to discuss here is now you must have heard about annular solar eclipse. Annular means Kankanakruti. It is a more familiar word. Kankanakruti सूर्यग्रहण आपण ऐकलेलं असतं. आपण चंद्रग्रहण कंकणाकृती आहे असं कधी ऐकलंय का? आपण ती पॉसिबिलिटी चेक करूया. Let us see if annular lunar eclipse can happen. So this is a typical picture of an annular solar eclipse wherein the limb of the disk of the moon is slightly smaller than the disk of the sun, and when it exactly coincides with the disk of the sun, the outer peripheral region of the solar disk is visible. So this is typically an annular solar eclipse, Kankanakruti Suryagrahan. It's a fantastic phenomena. Similarly, can we see this? The shadow of the earth is here and moon is slightly smaller than the shadow. Can this happen? Let us see the possibility. Now what happens is that during a solar eclipse, moon shadow falls on the earth, and the people living in that region, they will experience that moon has totally obscured the sun, and that way they will experience the solar eclipse. But in case of a lunar eclipse, what happens is that Earth's shadow is so large, so huge, that the moon is entirely engulfed in that shadow, entirely passes through that shadow. So in order to have a annular lunar eclipse, the moon should have been somewhere here, so that outer peripheral region of the moon should have been visible. But the maximum distance from the center of the earth of the moon is only 4,07,000 kilometers. So at that distance, the diameter of the shadow is more than 9,000 kilometers. So moon's diameter is hardly 3,476 kilometers. So it totally engulfs in that. So moral of the story, annular lunar eclipse never occurs. Never occurs. So that is the take-home message. So now let us see some of the phases of the moon lunar eclipse. Typically, you get timings of lunar eclipse. That's why I have inserted this slide to make you understand what are the different steps of a lunar eclipse. So P1, so the passage of the moon through the shadow is from right to left, this way. This is shown by an arrow. So at first instance, it will touch the penumbra. Then it will touch in UA, it will be touching umbra. In U2, it will be totally inside umbra. So that will U2 will mark the beginning of total eclipse. Then M shows the middle of the eclipse, because at that instant, the distance between moon's disk center and the axis of the earth shadow will be minimal. And then again U3, where the totality phase will be ended. U4, totally it will come out of the dark shadow, and by P4 it will be totally out of penumbra also. So entire span typically lasts around 3 to 4 hours, depending upon the speed of the moon, the shadow, the diameter of the shadow. A lot of things are there. So these are the typical phases of the moon, the phases in the eclipse of the moon. And you can see there are plenty of, nowadays there are plenty of websites where you can find the dates and timings of these events. And only you'll have to make sure that that eclipse is visible from your vicinity, because typically on those sites, especially NASA's site, you can see plenty of information about eclipses, but all those timings are in universal time. You'll have to convert those time into Indian Standard Time by adding 5.5 hours into that. So that way you can make out whether that eclipse is visible at your place or not. But typically, the plus point of lunar eclipse is that lunar eclipse occurs in this space. So what happens is that almost half of the Earth is in a position to see the eclipse. This is not the case with solar eclipse. We'll come to that. So this is all about lunar eclipses. I think it is fair enough to have that much exposure of lunar eclipses for now, because there is a lot of things to be discussed in solar eclipses. Solar eclipses, although the geometry of solar eclipses is exactly opposite of lunar eclipses, because the position is exactly 180-degree different, but yet there are so many things that needs special attention as far as solar eclipses are concerned. So this is the same thing I'm repeating. The only thing is this is the same diagram, but in case of lunar eclipses, what happens is that it's a full moon. So that's why the position of the moon will be somewhere here. But in case of solar eclipses, the moon has to be somewhere in this region, because this is a new moon or Amavasya position. So you can see that the shadow of the moon is falling in this direction. So the geometry is exactly 180-degree different than the lunar eclipse. So it is fairly easy to understand, because all these three bodies are there in solar eclipses as well. So now we are coming to the big question: what are the nodes? As the diagram in this miniature diagram, I have shown the intersection of the orbits of the Earth and the orbital plane of the Earth and the orbit of the moon. You can see that the arrow is shown here, so that the direction of moon's revolution is this way. Typically, all the planets are moved when seen from North Pole. They are shown as anti-clockwise in motion. So this will be the direction of moon's revolution, and this is the plane of the earth, and which is making an angle of 5 degrees. So you can see that there are two intersection points where these two planes are intersecting. So these 2 points are called nodes. Collectively, they are called nodes. But one is called ascending node, and very infamous name Rahu. So now you will come to know that Rahu is nothing but just an intersection point. Just an intersection point of what? The plane of the earth and the orbit of the moon. Very simple. Same way, there is one more point, descending node. Here we can see, here it is going down. So here it will meet another intersection point. And this is descending node, which is called Ketu. So Rahu and Ketu are they are no demons. They are just an intersection points of the orbital plane of the earth and the orbit of the moon. And how to identify who is ascending node and who is descending node? The point at which the moon's orbit goes to the north of Earth's orbital plane is called Rahu, and point at which the moon's orbit goes south of orbital plane, it is called Ketu. Rahu and Ketu, as simple as that. So it is near these points, and if at these points new moon or full moon occurs, then there is obviously the possibility of eclipses, because at this point the plane of orbit, the planes of these two objects are meeting. So that's why at this juncture they are in the same plane. So at this juncture, if full moon or new moon occurs, then there is a huge possibility of an eclipse. We'll come to that. But before that, we'll see quickly the types of solar eclipses. As I said, solar eclipses are the eclipse of the sun, eclipses of the sun. And you can see that sun's disk is partially blocked by the disk of the moon. How it occurs? It is the umbra is falling on the in the direction of the earth, but umbra is not touching here. In this case, only penumbra is touching the earth, and you can see umbra is not touching. So in this case, what will happen? The people living in this region, for them, this moon will partially block the sun, which is somewhere here, partially block this way, partially block the sun. And in that way, they will experience a partial solar eclipse because it is partially blocked. No? These people can see, even these people can see some part of the sun here. Only some portion of the sun is blocked. So that's why it is partial eclipse. Now, total solar eclipse is a very schematic diagram. I've shown the sun. This is the moon. And you can see right here, see minutely, there is a streak. This is the shadow of the moon passing across the earth, surface of the earth. So what happens is that the people living in this tiny region, this small region where the shadow is touching the surface of the earth, they will experience that the sun is totally obscured by the moon. So that's why this is called total solar eclipse. And this particular phase where it is obscuring sun totally, it is called totality. And totality is a wonderful event, a lifetime experience. I really have no words to explain that experience. And you can see the outer atmosphere of the sun, which is very difficult to see otherwise. So this outer atmosphere of the sun is called corona. And there is a lot of physics in this corona, obviously, because it is a very interesting region of the sun. So what happens is that moon being a very smaller object, its shadow cannot completely engulf the earth, just as we see in the case of the earth, where earth can totally engulf the moon in case of lunar eclipse. But in solar eclipse, moon shadow cannot entirely engulf the earth. So it is only a part, hardly 1%. See here, only 1% of the total area of the earth can be obscured by the moon's shadow. So that's why, so this is the reason why we feel that solar eclipse is very rare. In fact, it is not rare, but if you consider a specific vantage point on the earth, then yes, it is rare. It is very rare. So this is the typical, this is the path of the shadow of the moon, rapidly goes through across the land masses. In this slide, I have shown this path of the moon shadow that was on 22nd July 2009. And we had been to Jabalpur right here to observe that eclipse. But unfortunately, that was washed out because it was 22nd July, almost the middle of the monsoon. So we couldn't observe that eclipse, but that dimming of light and that phenomena we could experience. So so now next type is annular solar eclipse. We made a mention of that earlier, and we can see that see in annular solar eclipse, what happens is that it is obscuring the sun. Sun is in this direction. Moon is here. Moon shadow is falling in this direction. This is the earth. But what happens is that moon is little distant in its orbit from the earth. So that's why what happens, its dark shadow, umbra, is not reaching the surface of the earth. But what happens is that if you extend this this angle, you can see the reverse shadow. It's a reverse shadow. It is called reverse shadow that touches the earth. And people living in this region where my cursor is, this region, if you are in this region, what you will see that the moon is obscuring the sun, but its disk is not as big as the solar disk. So it is slightly smaller. So that's why peripheral region of the sun is visible. So that's why in people living here will experience an annular solar eclipse. This is the schematic diagram, how it overtakes the sun in the sky, because moon is much closer than the sun, it overtakes. And then we'll see this fantastic eclipse. This phase is called annularity. Annularity means, annulus means ring. This is a ring, it's annulus, it is called ring of fire, everything. So it is a fantastic phenomena, yet it is not, although it is covers, in most of the cases it is covers, the moon's disk covers 95 to 99% of the disk of the sun. Yet in the last eclipse occurred on 21st June 2020, we had been to Suratgarh, Rajasthan, and we experienced that even despite the moon covered almost 98% of the disk of the sun, still there was a lot of light. It wasn't dark. So that is the power of the sun. So just like solar eclipse, there is also, we can also show the path of the shadow of the moon across the surface of the earth. So this is typically the shadow of the earth on, shadow of the moons ran through the southern part of India on 15th January 2010. We had been right here at little ahead of Rameshwar. There is a place called Dhanushkodi, very beautiful place, where we could see that eclipse. And that was a long duration annularity eclipse. Annularity literally lasted for around 10 to 12 minutes, somewhere between 11, somewhere around 11 minutes. That was a long annular eclipse, because typically such phases last for few minutes, very few minutes. In few cases it is only few seconds. I will show you at the end of our lecture the video of our observation of last annular solar eclipse. So apart from these typical types of eclipses, there is one more very interesting kind of eclipse, which is called a hybrid eclipse, hybrid solar eclipse. And as the name indicates, it's a mixture of two types of eclipses. The one is total eclipse and one is partial, one is annular. So what happens is that in this case, the distance of the moon from the earth is so so typical that its vertex, हा जो शंकवाकृती आकृती आहे चंद्राच्या सावलीची, तिचं टोक हे जस्ट barely टच करतं. The vertex of the shadow of the moon touches the surface of the earth, but here you can see that it is not touching. It is ended here, but because of the curvature of the earth, at some point it is touching here. So it's the same eclipse which is visible from here as an annular eclipse because it is a reverse shadow, right? So from here where my cursor is, people living in this region will see that, okay, this eclipse is an annular eclipse. But people living here, they will say that, no, it was a total solar eclipse only for a brief time, but yes, it was a total solar eclipse. And again, people living here, they will say that this is an annular eclipse. So during a hybrid eclipse, the distance of the moon from the earth is so immaculate that its vertex of its shadow cone barely touches during the middle of the eclipse, around middle of that eclipse phase. So that's why these eclipses are called hybrid eclipses. Annular, total annular, ATA, annular, total annular eclipse. So now, now I was talking about the shadow of the passing of shadow across the surface of the earth. So this is a typical diagram that I have taken from 5 Millennium Catalog of Eclipses, which is available at NASA's website. It's a fantastic source of understanding eclipses and the dynamics of eclipses. And you can see that there are different types of shadow bands. Typically, the blue ones are total solar eclipses and red ones are annular solar eclipses. It is written here. So these are the passage of shadow of the moon. And you may wonder why these shapes are so bizarre. Because you see the shadow is coming, everything is moving. See, in a way, Earth is moving, Earth is revolving, Earth is rotating, moon is also revolving, everything is in motion. Plus, Earth is not, its axis is not straight, it is tilted. It is tilted with an angle of 23.5 degrees. So what happens is that because of the combined effect of all these things is that the shadow bands, the shadow of the moon's shadow passes across different land masses on the earth. And if you want to observe this eclipse, then you have to be right somewhere here within this path. Then only you will be able to see a solar eclipse. So this is the path of 2009 eclipse. You can see the date here. And this is the path of 2010 eclipse that we observed from Dhanushkodi. And this was the path that we observed from Suratgarh, Rajasthan last year. So these are typically three, four solar eclipses that occurred in last few years. And so you may wonder that what kind of shape this is. But if you see this is somewhere, these are the region where the midnight sea is seen. So these are the typical the regions where the Earth is so tilted that the region where there is a midnight, it is still in a position to see the sun, because despite of being at the opposite of the Earth, it can see the sun low on the horizon. So in this case, in this region, the shadow sweeps in this region because it's a cone, and it sweeps across this surface of the earth. So briefly, for a brief time, it can sweep in this way. So these are the different paths of the solar eclipses. And let me tell you the dates. These two eclipses are over now. We saw both these eclipses. Then on 21st May 2031, there will be annular solar eclipse from Tamil Nadu. And then in 20th March 2034, there will be a total solar eclipse from Jammu Kashmir. And then you can see there is a huge gap between these two dates, 2074 directly. So in order to see a total solar eclipse, either you have to wait till 2034 or you will have to go out of India to see that. So I would rather say don't miss any opportunity of seeing solar eclipses. See, watching an eclipse on a television and watching it on a broad daylight is totally different. There is no comparison for that. So you must necessarily go there and observe it. So now just few more points on the nodes. As I said that these are ascending and descending nodes, Rahu and Ketu. And as I said that if the moon, in case of solar eclipse, if a moon is somewhere here, then there is a chance of, if the moon is here and the sun is somewhere here in this direction, then you will see that there is a chance of eclipses. So around these 2 points, there is a high probability of eclipse, because around this point only, there will be a chance of shadow falling on these things are greater. For example, here I have shown you that ascending node is here, and supposing the orbit of the moon, as I said, it is making an 5-degree angle to this plane. So it is traveling in this fashion. And suppose at this point, when the moon comes here, the full moon occurs, then there is a chance that there will be an eclipse. Sorry, full moon, new moon, because it is obscuring the sun. So now I'm going to show you these 3 positions. This is M1, this is M2, and this is M3. And these 3 positions, and moon is at different position. And at this point, if new moon occurs, अमावस्या झाली, समजा इथे असताना एकदा झाली, इथे असताना एकदा झाली, आणि इथे असताना एकदा झाली. So now, when eclipse will occur? At M1, can eclipse occur? Yes or no? Probably no, because it is not in plane with this. So Earth shadow, moon shadow will fall in this direction, and we will not be able to see the eclipse. Probably M2 here. Yes, because both of them are in same plane. M3 again. You don't think that there is no reason why the shadow will fall. So what I want to point it out is that, does it mean that a moon has to be only on the node at new moon to have an eclipse? Is it so? Think twice, because it is not as simple as that. See this phenomena. M4 position. See here, if the sun is here, moon is here, as seen from the earth, moon is still obscuring the sun. Partially maybe, but yes, it is obscuring. So it can be a partial eclipse, right? So moral of the story is that moon is not necessarily to be on the node to have an eclipse, right? So that's where the question of eclipse limits comes. What does it mean? Eclipse limit means how far a moon can be from the node in order to have an eclipse. I repeat, how far the moon can be from the node to have an eclipse. Because the moon and sun are not point sources. Had they been the point sources, then yes, they will have to be on the node so that they will overlap each other. But they are not point sources, they are extended sources. So you saw that in M4 position, they partially obscured. So now this is the case. This is what I was trying to tell you. There can be, the moon can be as away from this node to this point to have an eclipse. See here also, no matter, very partially it is blocking the sun, but yet it is blocking, right? So it is still an eclipse. If you go further here, then it may not obscure, right? Same way here also. If the sun is here, because this is the sun's path, I mean apparent path of the sun, and this will be the path of the moon. So if the moon is here, sun is here, there won't be eclipse. But if the moon is sun is here and moon is here, yet it can. And if it is there, then it is surely. So what we can say that the eclipse limit can be an arc along the side of the nodes that we can mark, and we can call them as eclipse limit, because in that region, if full moon or new moon occurs, there are chances of eclipses. There are chances of eclipses, right? So these limits play a very important role. So putting those in figures, these are the limits of eclipses. So there can be a maximum and minimum limit. Maximum limit and minimum limit means, a minimum limit means the innermost arc within which if the moon is there, then definitely there will be an eclipse. But if it is between maximum and minimum limit, then see, for example, in this is the maximum limit and this is the minimum limit. So this is the minimum limit from here to here. Here to here, this is the minimum limit. So within that, if these two objects are there, then definitely there will be an eclipse. But anything between minimum to maximum, within this and this arc, in this case, eclipse may or may not occur. May or may not. Because at that time, the apparent sizes of both these bodies needs to be considered. If the moon is away, then the disk will be smaller. So it cannot obscure the sun, right? So in that case, there won't be an eclipse. But if the moon is very close to Earth, very close means, as you know, that moon revolves around the Earth in an elliptical orbit. So sometimes it is closer to Earth, sometimes it is away. And that's why we hear a lot of things about a lot of things such as supermoon and all that. Supermoon is what? Nothing but the full moon occurring at the point where in its orbit it is closest to the Earth. So at that time, if the moon full moon occurs, there is a possibility of eclipse. And you must have seen that in the last week only, we had a supermoon eclipse. Okay. So these are the, you don't need to remember all those figures. My point is just try to understand the concept. Okay. So we quickly go ahead. So again, maximum limit, minimum limit. So eclipse may occur here, may not occur here. See, the size is smaller than this thing. Moon's size is smaller than this. So that's why. So within maximum and minimum limit, eclipse may or may not occur, but within minimum limits, there will be surely an eclipse. Fine. So now eclipses, as I said, we are just now coming out of this mathematics and geometry. Let us come to some different topic. Eclipses and the development of astronomy. As I said, eclipses are extremely important things, important object, important phenomena, and they have contributed a lot to the development of astronomy. There are many discoveries that have taken place during the observation of solar eclipses, especially because solar eclipses are the events wherein you can study the sun peacefully. See, nowadays we have got different probes that are going to study the sun, like SOHO. Then we have Parker solar telescope. Then Aditya is also around the corner. So there are so many space expeditions that will go closer to the sun and take photographs and study the sun in detail. But in the bygone era, there was no source other than solar eclipses than to learn the atmosphere of the sun. Because on the broad day, it's very difficult to study the sun. And my advice to you is that never try to see the sun with unaided eye or through any instrument, because that will immediately damage your eye. because it's an intense source of light. It will damage your eye retina, and that's why it is that is the only hazard involved in the observing of eclipse. Only you should take care of your eyes. That's it, nothing else. But nowadays there are solar goggles, lot of filters are there through which you can see, and those filters need to be tested well. You need to see that there are no scratches or holes in that goggles or that films. Then only you should use them to observe the sun. So a lot of things were discovered during the observation of the solar eclipses. Change in the speed of rotation of the earth. As you know that the speed of earth's rotation is also slowing down, and this discovery was inferred rather than directly discovering. This was predicted that there must be the change in the rotation of the earth, um, and this was observed. This was postulated by Edmund Halley during his computation of the paths of solar eclipses. And then there was an eclipse occurred on in August 1868, wherein P. Janssen, who was a French astronomer who observed this eclipse from Guntur, India, and he noted that there is one more element which is not known to that date, and later on it was declared as a helium. So helium discovery was the outcome of the study of the solar eclipses. Then proof of general theory of relativity. In Einstein's general theory of relativity, it was predicted that the light is bent in the strong gravitational field. So what happens is that if there is an intervening strong gravitational field between you, I mean observer on the earth, and the source of light, then light coming from that source to observer can bend if there is an intervening strong gravitational field. So this postulate was proven correct during the observation of eclipse of 29th May 1919. And then again, the outer atmosphere of the corona that I showed in one of the slides, that its temperature is computed to be 1 million degrees, a very hot corona. So that study of the sun, that part of the study of the sun was also carried during solar eclipse. So now, big question, how to predict eclipses? It's a very tricky question. But for that matter, first you will have to understand lunar months relating to eclipses. So now by prediction, what I meant to say that by the end of this lecture, I'm sure I will give you enough clues to know the future date of an eclipse, and that too without going through any rigorous mathematics. So I think you will be able to predict the eclipses if I give you an eclipse date. So how to do that? That I'm going to tell you in next few slides. But before that, I will have to draw your attention on the lunar months relating the different lunar months, because it is directly relating to prediction of eclipses. So we say that moon is orbiting around the earth, and it is orbiting around the earth and makes an complete orbit in somewhere around 27 days. So that way it is, where the question of different month comes. We'll see how it comes. See, this is a schematic diagram where the earth is moving around the sun, and at the same time moon is also moving around the earth. So what happens is that because of this, we can see different phases of the moon. We call them as tithi. तिथी आपल्याला माहिती असतं, पौर्णिमा, अमावस्या, अष्टमी, प्रथमा, द्वितीया, तृतीया, हे सगळ्या तिथी आहेत. तर पौर्णिमा is also a phase, full moon. New moon is called amavasya. Then first quarter, last quarter is Krishna Ashtami and Vadya Ashtami. So these are different phases depending upon the position of the moon with respect to the sun and earth. In this case, it is Purnima, but if the moon comes here, somewhere here in its orbit, then it is making a right angle with the sun-earth line. So it becomes an Ashtami. Same way, if it comes here, then it will be a new moon, again new moon, Amavasya. So likewise, because of the different positions, we can see a different tithis. So now, one more aspect is that to add the complexity, The moon revolves around the earth not in a circular orbit but is an elliptical orbit, अंडाकृती or दीर्घवर्तुळाकृती orbit असते. So sometimes it is closer to earth and sometimes it is away. Sometimes it is closer, sometimes away. So that's why these things, putting these things together, we can have different types of months. We will see them one by one. Synodic month, very simple to understand. Don't go after this term synodic. मराठीत त्याला सांवासिक महिना म्हणतात. But we all know these months. Although I have introduced this term, I think there is no reason to fear this. This is only from one tithi to another tithi. Say full moon to full moon. For example, here you can see that this is the sun, this is the earth, and this is the orbit of the moon. Here, this is the position of a new moon. And as the moon goes around the earth is also moving around the sun. So it will come here. So in order to have next Amavasya, the moon should not be here, but rather somewhere here, so that they will be in one line. So this extra time should be added to the revolution period of the moon, right? So that's why synodic month is slightly greater than the moon's revolution period. It is somewhere around 27 days. This is 29 days because this extra time, because Earth has moved from this position. Had Earth been stand still here, then okay, yes. अभी एक बार इधर आया, वापस इधर आ गया, हो गया 27 days. Okay, fine. But Earth is not stand still. It is moving in its orbit. So it will come here. So moon has to cross this small section. So that's why it takes additional time. So these months, synodic months, that full moon to full moon or new moon to new moon, पौर्णिमा ते पौर्णिमा किंवा अमावस्या ते अमावस्या, हा जो काळ आहे याला सांवासिक महिना किंवा सायनोडिक मंथ म्हणतात. आपल्या जे कॅलेंडर मध्ये जे महिने असतात, चैत्र, वैशाख, ज्येष्ठ, आषाढ वगैरे, हे सर्व सायनोडिक मंथ्स आहेत, and which are very scientific because they are far more scientific than January, February, because they start or end with अमावस्या or पौर्णिमा. In North India, there are पौर्णिमांत महिने, म्हणजे पौर्णिमांत महिने नॉर्थ इंडिया मध्ये ऑब्झर्व केले जातात. whereas आपल्या वेस्टर्न आणि सदर्न इंडिया मध्ये, भारतामध्ये अमावस्यांत महिने मानले जातात, म्हणजे अमावस्यानंतर महिना बदलतो. whereas नॉर्थ इंडिया मध्ये पौर्णिमा नंतर महिना बदलतो. त्यामुळे थोडासा 15 दिवसाचा फरक असतो. That's just a convention. The idea is that it is following some scientific vantage points. So that's why these months are very scientific. Full moon to full moon or new moon to new moon. So synodic month, now the crux of the matter is here. Synodic month is very important because it governs the type of eclipses. See, unless and until you have Purnima or Amasya, you just can't talk about eclipses, right? So it has to be a full moon or new moon. So this synodic month is the most important type of month as far as eclipses are concerned. So now we will take some time quickly and go through this thing. This one more additional month, nautical months from node to node. I have told you about these nodes, nautical months from one node to another node. So since it is an elliptical orbit, it takes, sometimes it is faster, sometimes it is slower. When it close to the earth, moon is faster. When it goes away, it is slower. But what happens is that this nodal line is also not a stationary. It also moves in this direction. It also moves in this direction. It's opposite direction. Moon is moving in this direction, but this orbit is moving in this direction, sorry, this direction, clockwise. So what happens is that they meet somewhere here. As this, this is somewhere here. So it will meet not here next time, but somewhere here, because this line is slightly shifted in this way. So that's why this period is 27.21 days. Next month and last month, to add some spice to this discussion. Perigee and apogee, I have already told you that these because of this elliptical orbit, the moon sometimes is closer to Earth than the other times. Apogee and perigee are upabhu आणि अपभू जागा जिथे हे लॉंगेस्ट डिस्टन्स असतं अपभूस्थानी. उपभूस्थानी तो नियरेस्ट असतो आणि अशा वेळी जर फुल मून झाला तर त्याला सुपर मून वगैरे काय 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 म्हणतात. तर ओके, सो दिस फ्रॉम वन पेरिजी पॉइंट टू अनदर पेरिजी पॉइंट, इफ इट कम्स टू दॅट देन इट इज कॉल्ड अन एनोमलिस्टिक मंथ. नैदिष्टिक महिना असं मराठीत म्हणतात. थोडासा ऑड शब्द आहे, नैदिष्टिक महिना. So summarize, these are the different spans of these months. Synodic months, सामासिक महिना, new moon to new moon, 29 days. Sidereal मी तुम्हाला सांगितलं नाही कारण it has got no relevance as far as eclipse discussion is concerned, so you can simply ignore this. Then nautical months, 27 days, and anomalistic month, 27.55 days. So now the big question, sorry, I would request the organization if I can take 5-10 minutes more.
Yes, sir, sure.
Thank you. Okay, so now one more last concept to add this thing, then we can go to prediction. There is something called eclipse year. There is no reason to fear to that. See what happens, although it is the earth that moves around the sun, but since eclipse is observer specific phenomena, all the eclipses are observed from the vantage point of the earth. So from seeing from the earth, what happens is that we see that sun, moon, every planet is revolving in our sky, moving in our sky. So we can say that we can draw an apparent path of the sun in our sky. Although earth is moving around the sun, but since we appear to be stand still at our place, we feel that sun is moving in our sky. So what happens is that we can draw a line of the sun's motion in the sky. It's total 360 degree circle we can draw, and that completes in a 360 degree. So 1 degree per day. So please don't mix it up with the daily motion of the sun, apparent sunrise and sunset. That is because of the rotation of the earth. But here I am talking about the revolution of the earth. See, you must have learned about the one concept called in one festival we celebrate in January. 14 January, around 14 January, we enjoyed Tilguls because we mark the we celebrate the Makar Sankranti. So what this is, Makar Sankranti is nothing but the arrival of the sun in Makar constellation, Capricornus. Makar is Capricornus. So once suns come into the Makar constellation, Capricornus, so one way I am saying that earth is moving around the sun, but in here I am saying that sun is going to Capricornus, then Aquarius and all that. How it is? Both sentences are true because is a reference frame is different. Here I am talking that from the observer point of view, sun is moving in different constellations. या राशीतनं त्या राशीत सूर्याचं राश्यांतर होतं. मकर संक्रांती जानेवारी मध्ये होते. आता 6 जूनला, आज 6 जून आहे, आज बरोबर असा दिवस आहे की यावेळी सूर्याचा प्रवेश मृग नक्षत्रात होतो आणि आपल्याकडे पावसाला सुरुवात होते. सो दिस sun's arrival in Orion or Mruga Nakshatra is also one sun's position in the sky, right? So what I'm trying to point out is sun's motion in the sky. Same way we can draw the line of the moon's motion also, and there should be an angle of 5 degrees. So these two circles are nothing but that apparent motion of the sun, and this is tilted motion of the moon, and sun's arrival from one vantage point to again coming to that position. I'm talking about sun's motion. For example, आज सूर्य आला मृग नक्षत्रात, पुन्हा मृग नक्षत्रात किंवा या पॉइंट मध्ये येण्यासाठी जो वर्ष लागतं त्याला आपण 365 डेज म्हणतो. एका वर्षात सूर्य पूर्ण म्हणजे पृथ्वी एक प्रदक्षिणा पूर्ण करते, त्यामुळे आपल्याला सूर्य सुद्धा पूर्ण एक सर्कल आकाशात पूर्ण करताना दिसतो. बट with respect to the node, with respect to the orbit of the moon, what happens is that with respect to this nodal line, what happens is that as the sun moves in this position, this nodal line also slightly shifts from here to here. So next time it would be somewhere like this. Because of that, what happens? Because of that, what happens? Sun meets this node at this point instead of this. Because node has shifted somewhere here and nodal line is somewhere here, it meets little earlier than this position. And we know that had it been at this position, then it would have been 360 days. But it meets this node point somewhere here. So that's why this point, this one circle from one node to another node by the sun is 346 days. That is called an eclipse year. Because it's an year, it's not a month. So this successive arrival of the sun at the same node is 346 days. Whew. So now I will not take much time. I'm going to show you one very interesting phenomena, perhaps the most interesting phenomena of eclipses. Quickly run through. And this, we are now heading towards the climax of this presentation, I would say, because this is something very interesting. See, in bygone era, there was a king in Babylonian region, Nabonassar. He compiled a list of eclipses. He was extremely interested in eclipses. Now, he not only observed eclipses from his point, from his place, but also he compiled the dates from his resources and made a mention of those dates in clay tablets, on clay tablets. And then he found that there is a remarkable pattern in these dates. There is a remarkable pattern in these dates. And if you apply same context in today's era, then I would like to highlight these dates. See, there was an eclipse on 30th May 1965, then on 11 June 1983, 21st June 2011, and 2nd July 2019. These are proven, these are observed dates of eclipses, all solar eclipses. Now, if you carefully see, the duration between these dates is 18 years and 11 days or 10 days, 10 or 11. So the most important thing is eclipses are repeated after 18 years and 10 or 11 days. So if I give you today one eclipse date, then if you add 18 years and 10 days, or you deduct 18 years or 10 days from that date, then you will get another date of an eclipse, very likely, right? So this series is called Saros series. Saros, very easy to understand. Now we learned about that different months, synodic months, Tithi to Tithi, Purnima to Purnima. You take 223 synodic months, it will be 655.3211 days. You take 242 nautical days, one node to another node, Rahu to Rahu. असे 242 महिने घेतले. It will take that much days. If you take 239 anomalistic months, means perigee to perigee or apogee to apogee. And if you take 19 eclipse year, sun's arrival on same node from one point to another, you take 19 such years, then it's 6585.80. So what is the speciality of this? Speciality is this: 6585 is the integer. If you see, integer is same. There is a fraction difference in the fraction, but integer is same. And this 6585 is nothing but 18 years and 10 or 11 days. So this is the crux of the matter. And these two lines are the climax of this presentation. So the point is that what is the secret behind this repetition of eclipses is nothing but after 18 years and 10 or 11 days, the sun, moon, and earth come in the same position with respect to each other. So if today is an eclipse, the same position with respect to each other, then obviously there will be another eclipse. So likewise, these terms repeat. So we are again taking those dates. So each eclipse is separated by 10 or 11 days. And these eclipses are called eclipses in a single family of eclipses, And typically these eclipse families are called Saros families. These are having finite number of eclipses in a Saros family. And all these eclipses occur at same node because we are taking integer of that nautical month, right? So 242 nautical months. So that's why the same node will repeat again and again. Then remarkable similarities in the successive eclipses of the family. And like solar eclipse, lunar also eclipses also have Saros cycles because geometry is almost same, only 180 degrees apart. So same things repeat there also. So now when I'm saying that these 4 eclipses again I'm taking, so does this mean that there are no eclipses in the interim period? Does this mean that? No, because there were eclipses. There were eclipses in the interim period, but these eclipses belong to a different family. So all the blue eclipses are in one family. All the yellow eclipses are in one family, and all the orange or red eclipses are in one family. So simultaneously, there are many families running, right? So now the very interesting question thing, as I said, if you take one eclipse date, 14th December 2020, you go back 18 years, 10 days, you will find another eclipse. Go back yet, you will find one more eclipse date. Again go back, few more times. Similarly, you go ahead in time, add 18 days and 18 years and 10 or 11 days, add up, go on adding. All these are eclipse dates, and that's astronomy for you. This is the wonderful aspect of eclipse. See the sheer span. 17th April 1624, first eclipse of that family, to the last eclipse of that family will be on 5th June 2904. Kaun bachega? So this is just a one family of eclipse, solar eclipse. So there are a few questions about these families, but we will not discuss this because we are already past our stipulated time. But these are interesting questions. If you are interested in these questions, then go to some reliable information sources, especially NASA site or some book on eclipses, and read them. So now if you want to study this family, how do I mention this family, or how do I give nomenclature to them? So yes, there is a biodata of every family. Every family has got a number, Saros number 142. There are 72 eclipses in this family. Lifespan is 1280 years. First eclipse, middle eclipse, last eclipse date. Composition. In this family of eclipses, there are 28 partial eclipses, 1 hybrid eclipses right here, and 43 total eclipses. There were no annular eclipses in this family. And the sequence was, initially there were 8 partials, 1 hybrid, 43 total, then again partial. At the beginning and at the end, you will find partial eclipses at every family. And all these eclipses occurred at the descending node. So it's a Ketu family आहे. Ketu node पाशी झालेली family आहे. So last question. How to understand and why families? Okay. So last question is duration between two successive. Okay, life of a Saros family. So in order to understand the life span of a Saros family, let us go to eclipse year. Sun's successive arrival at the node, that is eclipse year, 346 days. You take 19 eclipse year, it will become 655.78, and 223 synodic months is this much. So difference, there is a, we talked about the integer, but now let us talk about the remaining part. So this, due to this fraction, what happens is that Sun lags behind its earlier position with respect to the node. So when I showed you the eclipse limit, I told you that this in a table I showed you that that entire the maximum to maximum limit is a arc of 36 degrees, 36 degrees, right? So every eclipse will keep happening within that span, and after around 72 eclipses, the sun will drift away from the node, and subsequently it will go further than the maximum limit. So that way it will be an end of the Saros family. For example, I'll show you here how it happens. At first eclipse of the Saros family, sun is here. The first partial eclipse of that family will occur. But after so and so years, one Saros period, that is 18 years, what will happen? Due to that difference in the 0.45 difference, the position of the sun will be slightly different. So with each successive Saros period, the position of the sun will keep drifting. It will keep drifting almost 72 to 73 years, 73 iterations. It will keep drifting, and one point of time, it will go beyond that. It will go beyond that. It will keep drifting, and one point of time at the 72nd eclipse, it will be here on, and after that, it will be out of maximum limit. See, this is maximum limit, out of maximum limit. So no way, whatsoever condition, the eclipse will not occur. So that will break the chain of these eclipses. So that marks the end of the remarkable series of eclipses. So that's the point. That's how Saros families take birth, evolve, and die, but continue to amaze us. It's very interesting phenomenon. It's very difficult to explain all aspects here. I really apologize that some sort of bombarding I have done, maybe. But I just wanted to give you more than the basic things. So that's why I talked about different types of months and different types of the families in the Saros cycles. So each aspect is makes every eclipse in the Saros family gives little different. Every eclipse is slightly different than earlier eclipse in the Saros family. That is very interesting to know, but we'll talk about that sometime later. So thank you very much. Over to you, Yashodan.
Thank you so much for this information, sir. I believe that you have helped us establish a firm, if not a basic understanding of the topic at hand today. It was really educating to glean this information and kindled in us a desire to learn about the stars and the astounding physics behind it. Before we proceed to answering the various questions that we have received from the viewers, I would like to announce some of our future programs. On the 13th of June, we are organizing a small annual get together for all our JSS members. Updates regarding its various programs are already being posted on our Instagram page, Janaseva Samiti. The main program will be broadcast live on our YouTube page at 6 p.m. sharp. The message for the same will be sent along shortly. On the occasion of the International Yoga Day on the 21st of June, we usually hold a grand day-long program at Dubhashi ground where we assemble and perform Surya Namaskars. But given the COVID situation that is going on in the country, we decided to give this practice a remake. All our participants have to perform Surya Namaskars at home or at your workplaces and message us the number of Surya Namaskars performed. We intend to best last year's tally of 780 participants performing over 22,000 Surya Namaskars, and we need your help to do so. A detailed message regarding this will be forwarded shortly. Stay tuned. We have received many questions from our viewers. Shishir sir, let us address them now. The first question: can you share the formula for calculating high or low tide timings and heights for a particular area?
I think the computation of high tide and low tide is beyond the scope of this presentation, because this is all about eclipses, and the high tide and low tide comes in the dynamics of the gravitation force of the moon and the earth. So I think this would be discussed in a separate session, and we can now let us discuss on eclipses.
The next question: solar eclipses occurring at the same place has a frequency of almost 310 years. So, is it related to the revolution of Earth around the sun?
No, actually, I'm not too sure whether where this number comes from. But what happens is that the solar, there is no fixed pattern of solar eclipse occurring and being visible at same point of time, same location on the Earth. Because sometimes that, if you take a particular vantage point on the Earth, and if you say that, okay, today we have experienced a solar eclipse from this point. Now the next eclipse visible from the same location will be after so and so years. There is no fixed pattern, because sometimes it is the duration between consecutive eclipses is very short, and sometimes it is too large. I'll give you one example. As I have in one of the slides, I have shown that there are different paths of the moon's shadow that crosses the surface of the Earth, and because of the position of the Earth, moon's distance, the width of the path and the length of the path is differs. When if the moon is closer to the Earth, then obviously the width of the path will be much broader. But if it is away, the path will be much slimmer, or very tiny, or very slim path will be there. So what happened is, if there was an eclipse visible from London, and I don't remember the exact dates, but the consecutive duration of a total solar eclipse visible from London was somewhere in the order of 800 years. But at the same time, we have witnessed two eclipses visible from Vadodara city in the span of 11 years. For example, in 1999 eclipse was visible from Vadodara, and at the same time 2009 eclipse was also visible from Vadodara. If I'm not making a mistake, these two eclipses are very hardly a span of 10 to 12 years. So there is no fixed pattern as such, but you need to understand the different circumstances of the eclipses, the distance of the moon, the speed of the moon because of how far it is from the Earth, and the width of those things govern the width and visibility of an eclipse from a particular vantage point.
The next question: by observing the phases of the moon, can we get an idea as to where the nodes are located in the sky?
It's a fantastic question, very good question. By observing that, imagine, I mean, this is good, but by observing mere phases of the moon, you may not be able to get the inkling of the where the node is. But if you try to visualize where there is something called the Shrungonnati, or cusp of the moon. moon's crescent moon, if you see the crescent moon, at the time of the sunset, if it is tilted in the direction of the obviously it will be sunlit in the direction of the sun, and if it is tilted, then you can see that the sun is somewhere in the right direction. For example, you are facing in the west horizon, and if you see moon on the west horizon and its north cusp is tilted, then you can say that sun must be in that direction, towards north. At the same time, if you see in the early morning sky, if you see that cusp is tilted in reverse pattern, then you can say that the sun, although it is not visible, maybe in the early dawn hours, if at all the sun is not visible, you can make out where the sun would be. And when we say sun, then the node has to be on the line of the sun. So in that direction, there that node will be lying. So by observing the cusps of the moon's crescent moon, you can get little idea about the node. But exact precise location of the node would be difficult to point it out.
The next question, what was the reason that the outer atmosphere of the sun was labeled the corona? And is there any relation of the nomenclature to the SARS-CoV virus that we are calling the coronavirus?
It's a very interesting question. The reason why it is called corona is that if you have seen that particular slide when I have shown the total solar eclipse, you can see that the background of the solar disk can see the outer atmosphere of the corona. That corona looks like a crown. So from that, the word has evolved as a corona. Corona means crown. That word has come out from that nomenclature. And as far as coronavirus is concerned, I'm not an expert on coronavirus, obviously, but what I have learned, what I have read about corona is that the virus has got a similar structure like a corona. So that's why it is called coronavirus. That name is also come from that. So that way it is.
Next question. Does the ratio of the size of the sun, moon, and earth and the relative ratio of their distances play a part in the total solar eclipses?
Yes, obviously. Plus, before going to that, please once again repeat that question.
The question was, does the ratio of the sizes of the sun, moon, and the earth and the ratio of their relative distances affect the total solar eclipse?
Obviously, very fantastic question, very nice question, because this is the aspect which plays very important role in eclipse dynamics. Because as I said, the position of the earth in its orbit and position of the moon in its orbit plays a very important role. And let it be solar eclipse or lunar eclipse, the observer is in the normal circumstances, observer is will be observing that eclipse from the earth. So from earth, any vantage point of place, if you are looking at the disk of the sun and disk of the moon, their relative sizes makes a lot of difference, because particularly when the earth is closer to the sun, generally it is in the month of January. At the time, what happens is since earth is closer to the sun, the solar disk is much bigger. And on the contrary, in the month of July, it is away from the sun. That is aphelion point in the orbit of the earth. So what happens is that in the July eclipses, all the eclipses in the July, most of the eclipses, total solar eclipses in the July are long duration eclipses, because the apparent size of the sun is smaller and the apparent size of the moon may be average or bigger. If it is bigger, then it will make even longer eclipses. So most of the eclipses, total solar eclipses occurring in July are long duration eclipses. The longest duration total solar eclipse will be occurring on 16th July 2186, 21,186. And that will be a totality of duration 7 minutes and 29 seconds, I guess. So And also in 1991 also there was one July eclipse visible from Mexico. It was also a long duration eclipse. Then 22nd July 2009 that we tried to observe from Jabalpur, although it was washed out. It was also a long duration eclipse. So July eclipses are normally very long duration total solar eclipses, and the simple reason is that Earth is away from the sun, and the sun's disk is much smaller. Since it is smaller, the moon will obscure it for a longer time. So that's the crux. And on the contrary, January eclipses are in January. If there is a solar eclipses, there is a high chances they are long duration annular solar eclipses, because sun's disk is bigger, because Earth is closer to it, and moon may be average or smaller. Then in order to cross the solar disk, it will take more time. So it is longer duration annular solar eclipse. We observed 2010 January 15 eclipse from Dhanushakodi. That was in the month of January. And as I told you at that time, it was a long duration. The duration of annularity was somewhere around 12 minutes. So it's a very long eclipse. I think it was the longest annular eclipse of this century. So that way it is. It does make a lot of difference. So best eclipse, best of the best long duration totality eclipse. What will be the ideal condition? Sun should be smaller. That may be the Earth should be away from the sun, and moon should be closer to Earth, so that its disk will be bigger. So smaller disk obscured by bigger moon, so it will create a longer duration eclipse. So that's why July eclipses are longer duration eclipses, total solar eclipses. I think that answers the question.
Indeed. And last question, sir. Have there been occurrences of eclipses on planets other than Earth, and have they ever been captured by spacecrafts doing their bypass of other planets?
Okay, it's a simple as well as interesting question. So the simple question is that simple part is that obviously there are eclipses occurring on other planets also, because many planets have satellites, of rather a family of satellites. So eclipses do happen every now and then there. I don't remember. I sorry, I have not I don't remember as this point of time whether it was captured or not. But I think yes, there can be a lot of instances, because nowadays there are many rovers and spacecraft that are revolving around different planets. So they must have captured something. I'm sorry, I'll have to search, but it is not very uncommon or very rare thing. It is very common.
That brings us to the end of the program. Thank you everyone for attending. Once again, be sure to like, share, comment, and subscribe to Janaseva Samiti Ville Parle to stay updated. I thank Mr. Shishir Deshmukh once again for presenting such a wonderful program and